Let's say I type something on my computer, but now, how does my computer actually remember that I typed that? Many of you know that computers communicate in binary, that is ones and zeros. But how does the physical material that my computer is made of actually remember and store this binary information for me to view at a later time?
My name is Shayan, and today I'll be sharing my insights on the physics behind computer memory. Computers use silicon chips that are made of silica sand, and yes, there are beaches of it. But how do we save information on sand? Well, I'll make sure you know how by the end of this video. Firstly, in order to store information, a computer needs to register it. It does so by measuring an electric potential, or voltage, in volts. This is the same type of voltage you get from your 120 volt power outlets or AA batteries. However, you cannot measure this voltage directly from the power supply. Let's say you want to measure some volume of water from your kitchen faucet. You can't do this straight from the faucet. You need to hold the water in a glass first. A device called a capacitor stores charge from a potential source such as a battery in two metal plates, just like a glass stores water from a faucet. The plates are separated by a non-conducting material, and the accumulation of positive charge on one plate and negative charge on the other creates a potential difference across them, thus forming a way to store the voltage from the supply. When the voltage measured from the capacitor is 0 volts, the computer registers it as a binary 0, and when the voltage is 5 volts, it is registered as a binary 1. Depending on the non-conducting material, the capacitor can hold its charge for a few hours to a few years, so it is ideal for storing information. So we did it, right? We have now registered and stored binary information? Not exactly. Recall that we need either 0 volts or 5 volts stored in the capacitor. That means we need to control how much voltage is actually supplied to it. But how do we get a controlled voltage on a capacitor for it to actually store binary information? This is where it gets really interesting. Let's go back to the use of silicon chips in computer memory. Silicon is a material that is naturally non-conductive, so it will not allow current flow until it is introduced to impurities that make it conductive, thus creating a channel for charges to accumulate on the capacitor. But why not use a conductive material such as copper to start with? Well, a junction between silicon wafers possesses the ability to control the flow and direction of current, which gives us our desired 0 volts or 5 volts and makes silicon the most suited material for circuit components called transistors, thus the breakthrough. So let's tie these concepts together. What I type is read in binary and translated to voltages, which is channeled by a transistor made out of sand and finally stored on a capacitor. All of this is one bit of your computer's billions of bits of memory. And that is how you get computer memory from silica sand.